Hello and welcome back. In this video we discuss about Buckingham's Pi theorem, which is used for deriving relevant non-dimensional groups in a given problem. We have seen earlier that the dimensions of the basic physical quantities such as mass, length and time are represented using letters m, l and t respectively. For derived quantities, the dimensions can be derived from their units in terms of basic dimensions m, l and t. The Buckingham's Pi theorem is used for deriving relevant non-dimensional functional groups involved in a problem. For example, consider a problem of pressure drop in a pipe of length L. The pressure drop in a pipe depends on several parameters such as fluid mean velocity V, diameter of pipe D, density of fluid ρ, coefficient of dynamic viscosity mu, length L, and surface roughness E. As we discussed in the previous video, systematic experiments to study this problem varying a parameter one at a time is not practical. The variables examined in the experiments can be combined to generate non-dimensional groups so that a functional relationship between these groups can be found out from experiments. In this video, we discuss how systematically we can derive such non-dimensional groups using Buckingham's Pi theorem. To identify relevant non-dimensional groups, the first step is to arrange the dimensions of all variables in terms of basic dimensions m, l, and t in a matrix form as indicated. The next step is to find the rank of the dimensional matrix. In this case, the order of dimensional matrix is 3 by 7. The maximum possible rank in this case is 3. If we can find a 3 by 3 submatrix with non-zero determinant, then we can say that the rank is 3. For example, consider 3 by 3 submatrix consisting of last 3 columns of the dimensional matrix. We can see that this submatrix has a non-zero determinant. Therefore, the rank of dimensional matrix is 3. If all 3 by 3 determinants are zeros, then we may have to consider 2 by 2 submatrices and determinants to find out the rank. Now for the present problem, the rank of dimensional matrix is 3 and the number of variables involved are 7. According to Buckingham's Pi theorem, if there are n variables and the rank of the dimensional matrix is r, then we can derive n minus r non-dimensional groups. Therefore, we can derive 4 non-dimensional groups or pi groups in this problem. The next step is to select any 3 variables as repeating variable from the 7 variables involved in the problem. The number of repeating variables to be used is equal to the rank of the dimensional matrix. These variables will be repeated in all of the non-dimensional groups pi 1 to pi 4. Now we discuss how we select these repeating variables. The thumb rule is that the repeating variables must have different dimensions and among them must contain all the fundamental dimensions m, l and t. In many fluid flow problems, we choose a characteristic velocity, characteristic length, and a fluid property as repeating variables. For this problem, let us choose u, d, and ρ as repeating variable, where u is velocity, d is diameter, and ρ is the density. For each non-dimensional group is formed by combining the 3 repeating variables with one of the remaining variable. For example, let the first non-dimensional group can be written as pi 1 equals u raised to a, d raised to b, rho raised to c times delta p, where a, b, and c are constants that can be found out later. Now we have a pi term with no dimensions on the left side that can be equated to the respective dimensions of terms in the right side. Equating the indices of m, l, and t, we can derive 3 algebraic equations with the 3 unknowns a, b, and c. Solving these equations, we find a, b, and c, and substituting these values, we get the first pi term as delta p by rho u square. For finding the second pi term, we can use the 3 repeating variables with the next parameter l. Using the same procedure we have done for deriving the first pi term, we can find the unknowns a, b, and c in this case also. The second pi term can be derived as L by D. In a similar fashion, we can derive the third pi term as E by D and the last pi term as mu by rho RUD. Once we have all relevant non-dimensional groups, we can represent them as a functional relation with the independent variable on one side and the rest pi terms on the other side. Now, designing proper experiments, we can identify the functional relationship between two of these non-dimensional groups, keeping others constants. Thank you for listening. Keep watching tied-up video demonstrations of fluid mechanics concepts.